Hi everyone again to our evening session, and I'm happy and proud to welcome Søren this evening. Nice to have you here.
Thank you very much, Stefan.
Thanks. It's just actually near Christmas time, so that you spend the evening with us, that's just awesome. And
Yeah.
You have a family, as you said, with 4 kids waiting for you.
Yeah, exactly. But,
Fantastic.
Just have to be patient.
That's good. That's good. So I think we have an interesting subject, and but let me help you to introduce you a little bit to the audience, of course. Søren, you are located in Denmark, yes?
Copenhagen, yes.
In Copenhagen, fantastic.
Yeah.
Cool city. I would say nightlife, because nightlife. Okay, we have a little bit a problem with a crisis at the moment.
Exactly.
That's a beautiful city. What are you doing in your daily job?
So daily job is director in Ernst & Young. So I'm heading our AI risk team in Copenhagen, where we are helping clients with navigating the treacherously dangerous world of AI.
The dangerous world of AI. Okay, that's like, I think you're hearing something like a thriller story this evening, right?
Yeah. So it's with applications in the financial sector. So that's my main line of business, and something I've been doing for quite some time. But I've only recently joined Ernst & Young. I used to work for a bank, doing the same kind of activities. But now I have moved into consulting to help a broader range of banks and other financial sector companies.
Yeah. So why do you think risk is so sexy that you spend the whole working time on it?
So just trying to do what I can to help. And I think it's topical and relevant, and actually a particular perspective from the financial industry, which might be very relevant to other parties. So we have a long history, a pedigree of managing risks in the financial sector that might be of benefit to other people.
Yeah.
So, yeah.
Well, what are you from a background? What's your background?
I'm actually, I used to be a molecular and evolutionary biologist a long time ago. So I moved into computational biology, did my PhD in AI and machine learning with applications to bioinformatics. I've been a researcher at university studying models, disease interactions, various types of inference analysis. I've done a brief stint as a algo trader, so I wrote programs that traded in FX. So billions, not billions, maybe just millions, but still a lot of money on my laptop for a small startup. And then I've worked in the financial sector for a bank, doing model validation to start off with, primarily for pricing models, so various types of stochastic differential equations used for exotic derivatives, but then also over time, more generally, model risk governance, writing policies, rolling out the principles of model risk management out to new areas, and then for the past 3 years, establishing dedicated AI model validation team, looking at model risk of AI and machine learning applications. So
that's quite interesting. So nice collection of expertise, to be honest.
Yeah.
Did you ever experience, or looking at the topic of today, risk, and looking at your background, did you have ever had sleepless nights or nightmares because of risk in AI?
A few.
A few, okay.
but that's how it is. I think you learn to live with it over time. But there are a few potential calamities out there. I've also had sort of been chairing roundtables with leading banks in Europe,
Yes.
and interacted with regulators and supervisors on the topic, and sort of collaborated across the globe actually with people. And now that I'm in a very big company consulting other companies across the globe, that has brought a sort of broader perspective to that. But there are some concerns for sure. But as you will see when I go through my presentations.
Awesome.
So,
I mean, it's actually a perfect timing for me, to be honest, because I have to read a lot about risk management at the moment.
Mhm.
I have to. No, it's more like I do that because it's quite interesting at the moment.
Yeah.
I'm concerned about the black swan. I'm sure you probably heard of that. Nothing
Yes,
about
yes.
it stuff. And just nothing is predictable. So that's one of the messages I got.
Yeah, yeah.
Forget about that. Those things which are just boom, yeah, with the big events can cause so much trouble that we can't predict them. And so I'm really curious about to listen to what you have to tell us today. And so say, take the floor. It's yours.
Yeah, thank you. I'll just share my presentation here.
So one thing before we start, you can prepare your presentation. For everyone who had just joined, remember how that works here. So we have a Q&A section. If you look in the navigation bar, you can find the Q&A. You can always ask questions during the presentation. Søren can absolutely focus on what he wants to tell us and share his expertise here. I will take care about your questions, and I will ask all the questions when we come up and it makes sense, or at the end. But usually I ask the questions during the presentation so that we can really follow up. So there are no silly questions. This is the one thing I can say. Don't fear punishment or something like that, or laughter. Nothing happens, right? Just ask the questions you think are just painful for you and say, I need to know that. I'm curious. And yes, so we are here to answer. Søren, now it's up to you.
Thank you so much. So the title of my presentation is Move Fast Without Breaking the Bank, which is of course a little bit of double play on cost reductions and potential sort of issues for the financial sector and banks in general. I do apologize upfront for puns, even though this is a relatively serious matter, of course. And also the concerns are sometimes of great sort of concern. There is a little bit of humor, so I hope you also humor me, and don't take that take that up badly.
No,
So the main
definitely not, Søren. Definitely not.
good, good.
Honestly, if the more serious it is, the better humor is, right? So
yeah.
Go ahead.
So the main topic is AI risk, and particularly with the outset of model risk management as used in the financial sector as applied to AI. So perhaps before I start, I need to stress, so when people say AI risk management, there's two meanings of that. One is the use of AI for risk management, and the other one is risk management of AI. And of course, we use AI to do risk management of AI. But the main topic here is risk management of AI, not as much the use of AI for risk management. So the first thing, for some reason, it doesn't change. So here we go. There you go. First thing I would like to talk about is the perspective. So of course, managing risks is a crucial and central part of developing AI and machine learning applications and using AI and machine learning applications. And there's a lot of focus on that. Most of the heat currently in the general field of AI and machine learning is on the development side and the use side. Finding new applications, finding new techniques, getting sort of accelerated activities across the line in terms of developing platforms that can help people out with MLOps and all those things, but also just finding new applications. The other perspective to risk management of AI is the control component. The financial sector is, and especially banking, is all about control. So governance, audit trails, making sure that the money is there now and also tomorrow. So people can buy houses, get loans, pay for food, those kind of things, go on with their daily lives. That's the main sort of at the core of banking in particular. So that control component is very important to the financial sector, which is also the main line of work that I'm going to present for the rest of the presentation. Is going to focus on the control perspective on AI. And that also is just as for development, you can go from sort of frameworks, platforms, sort of full enterprise solutions down to individual application. The control elements also run the full spectrum from frameworks, how you set up the governance, to what you need to do for the individual applications. Most of what I'm going to talk about is not going to be the itty-gritty details, the gory details of particular applications of AI and machine learning techniques to particular sort of problems, but are going to be of a more general nature. There will be details and also a little bit of gore, but but perhaps not as much as some people might want to know about how is this being used in the financial sector. But just to give,
I'm fine with that, because I was actually expecting more kind of overview. So thinking about risk management in that specific industry, what does it really mean? So what kind of things we need to consider? So something like that.
Yeah. So just to give you a temperature reading on sort of the current status of AI and machine learning in the financial sector at large, but also for banks, is that there is a lot of activity going on right now. So there's rapid uptake of AI. It's still early days, both in terms of the use of these techniques and also of the underlying technologies. The applications are quite wide-ranging. So from various fin crime prevention tasks to customer satisfaction analysis, chatbots, data masking, textual analysis, model validation as well. And also the techniques being used are also quite varied. So from symbol-ish regression type techniques to more sophisticated, complicated setups like deep neural networks and reinforcement learning or causal inference. So the full spectrum. And of course, there's a lot of variation across the industry in terms of how many individual organizations are using which techniques for what applications and the maturity generally in the field. But we are seeing across the industry uptake and use of these techniques. And of course, that will bring across the globe significant benefits. So a lot of efficiency gains, a lot of improved processes, improved performance, but also naturally, the flip side of the coin is that this also brings risk and new types of risk. Yeah, you have
a quick question, just because out of curiosity, because you have AI use cases, AI techniques. Do you have any kind of insights about the trends? So what is there kind of some parts of it specifically of interest at the moment in the industry?
There's a lot of talk about the use of these techniques in credit, and I'll get into that a little bit later. But I think sort of overall trends are really hard to spot, except that there is more widespread application than so it's the trend is that things are growing, and it's becoming more varied. There's still a tendency to not use the most sophisticated and complicated techniques for high risk applications, thankfully. But otherwise, no, it's hard to spot a particular trend in this, except growth and applications across the board.
So it's more like we need to do the things we have to, but it shouldn't be too risky, right?
There's some element of that, but still also room for improvement on that aspect.
Okay.
So in terms of risks, there are what we call model risks in the financial sector, which is typically something which has been used as a particular risk discipline for managing complicated math, dangerous math, associated with pricing models, so exotic derivatives pricing, for market risk and counterparty credit risk, and for credit risk, which is also, of course, of paramount importance to banks. These new types of techniques and uses do bring a lot of operational risk in addition to the model risk as well, sort of a more manual types of errors and problems that can rise. Of course, also compliance risk. Are we compliant with the regulation? Are we compliant with our internal rules? Are things done by the book? Even in these sort of complicated settings. Security risks as well, associated with the use of sort of broader open data sources, and the possibility of, also due to complications from using sophisticated techniques, also that there might be vulnerabilities in this that can be utilized by ill-minded adversaries. Risk related to broad regulation that might lead to fines to the institutions, and of course, if you do dodgy things with your data without the consent of your customers and clients, severe reputational risks of using these techniques, and then also societal impact of using these techniques in terms of making your workforce redundant, using a lot of CO2 emissions from heavy training or using your server farms, right? And these risks can, if they materialize, so become losses, of course, that range from, first impact, of course, is loss of your investment in your AI and machine learning project because you fail. You might end up paying for your investment 3 times. First, from building it. Secondly, from realizing that it doesn't work and then cleaning up after it. And then thirdly, for re-implementing a proper solution that actually works. So it can be a costly, so even putting return on investment into the negative territory. So basically losing money on this. Of course, depending on the application, you can also suffer direct financial loss by these models or applications if they do not function as intended. You can lose revenue. There is, for grave, severe mistakes, the possibility that supervisors will impose additional capital requirements or fines, even massive fines. Ultimately, issues related to reputational risks, if it becomes sufficiently severe, you do run the risk of bank runs, which is a complete loss of trust in the bank, getting all the customers to withdraw their funds simultaneously. And then in the event that the bank cannot fund this short-term in the market, that leads to capital and liquidity issues, which is why we do, have regulation in place and supervisors to make sure that this doesn't happen, because that's a unfortunate sort of property of money, as clever as it is, and as easy as it is from your day-to-day work, that you don't need to go to some farmer and barter your stochastic differential equations for corn, that money can disappear. If you lose trust in money, in banks, then it evaporates, basically.
You can look for a new job.
Yeah, not only that, but people cannot then pay for their houses, cannot pay for food, and also due to systemic risks, this can spread across the globe and cause financial sort of system issues, as we've seen in the last financial crisis. That was not triggered by AI machine learning, but there's still a possibility that these kind of uses, if they are important and do not work as intended, can potentially trigger the same kind of sort of worst case scenario. And it's definitely something that people need to be aware of. And that means, of course, also that the license might be at stake for running a business as a bank. If you do not act responsibly and mitigate and manage the risks associated with using sophisticated techniques for important tasks. In terms of what causes these problems, our experience is from interacting with people across the industry, and also generally, yes, of course.
If you could just go back, so one thing is because there was a question I would like to address also is immediately. Lauren asked regarding the slide before, the 2 slides before the slide you're showing here. Is NLP as a natural language processing used as well? I guess so. Yeah, because this is, I think, one of the main application areas is just using it in the finance industry.
There's a lot of different applications of natural language processing. So document tech, information retrieval, processing of financial records, multiple use in chatbots as well, of course, responding to that. So multiple uses of natural language processing as well.
Thanks. That was the second question from Lauren as well. So you're asking for use cases. Now you named them, right? So if you go to the next slide, that was the question I would just ask as well. This is a huge, long list of risks, right? This is just like, wow. Shall we really start to build a model? That would be my next question. So looking at a team and the teams actually working operationally on building models, it's like it should be a huge team, right? You have to have people from a huge set of skills from the beginning.
Yes, and experience. But this is not too different from what is the case for other types of dangerous math. So you have the exact same problem with other types of models. I think the widespread use and the sort of distributed use for AI machine learning does put, makes the problem worse in many respects. But I'll come back to that on the risk drivers actually for my next slide. But the worst case scenario for just to go through these risks is that you have you use an AI machine learning application that is fundamentally flawed, doesn't do what it says on the tin. It breaks down constantly. It's non-compliant with your rules. It's vulnerable to attack, and you get a fine. And you're also using customer information and acting in ways that are, to the detriment of your customers, and you have laid off quite a substantial amount of your workforce for this broken machine. And if that leads to not only loss of your investment, but potentially fines or issues related to your license. That's the kind of territory that we're trying to avoid and get out of by any means or by particular means actually. So which I'm going to go through later on how we can not do those things.
Yeah, interesting.
But the problem is, so this is not particular sort of for necessarily restricted to the financial sector or only my experience or those of my colleagues. Generally, there's a very high failure rate associated with most AI projects. Of course, it depends on what server you're using and how they ask for it, but surprisingly many AI projects fail because it's not easy. I think people tend to underestimate how much effort you need to put into this. Just like any other thing that's complicated and important, you need to put in the effort. And there is a tendency to underestimate it. One of the problems is that again, across the board, I can't remember exactly where these statistics are from, but one survey showed that, I think it was from Kaggle, that 40% of AI developers had less than 2 years experience, which is quite substantial. And then when you go to people who are not developers, so all the control functions, your compliance functions, your operational risk, your legal departments, your senior management, your supervisors, they have practically no experience with AI and machine learning.
Can I comment on that for a second, Søren, because this is quite interesting. So 40% of AI developers with less than 2 years of experience. I found, I think it was from Andrew Nick's deep learning newsletter just recently, an interesting discussion about experience and lack of experience. And the point is, and that was an interesting point, that some of the techniques we use today are just so young, but where experience is not a matter of issue because it's just too young. And so it's probably more that we have to label those projects more as an R&D project and less than just like we do something and know already what's happening. Because it's still R&D, right? Yeah.
So it's very much the novelty. Yes. Also, just it's even if the techniques are, some of them are quite old, that they actually work to the extent that they do if you do it properly is also new. Yeah. So back when I did my PhD, neural networks didn't, of course they did work, but they didn't work to the same extent that they do now. And we've seen massive improvements, very, super compelling, massive breakthroughs in terms of using these techniques for playing poker, folding proteins, driving cars, doing all sorts of wonderful things that basically weren't just possible just a few years ago. But there are some, issues apart from that related to this, which I think leads to these potentials for using broken prototypes, and that are poorly documented as well, because the junior level of developers and not necessarily also people who like writing down what they do, especially from the beginning. And that's driven also by this, data-driven approach. Data science is a lot of data, perhaps not enough science, but still availability of open source software, of data, that it doesn't take long for, very sort of broadly speaking, to just take a course on Coursera or similar sort of open university something, get some open source software, put it on your laptop, get some data sets, try out some different things, and it compiles, it might work, you have your prediction performance being oomped somehow, and then you just go to production. Which is not how things should be done in a bank. So the ease of prototyping is driving some of this early uptake of immature, undocumented models. And there are also other issues related to inappropriate use of metrics, building up technical debt, and also this fear of missing out, that your competitors are also driving the use of these techniques, and that you're going to miss out on the opportunity of not doing this, and also a severe cost focus, because a lot of these, that's the artificial intelligence, is that a lot of the applications are intelligent in the form that they are used for tasks that was otherwise done by human people, but by humans, by ordinary people, right? Not in artificial people. So that means that you can save a lot by using machines rather than people. It also means that managers think they know what people are doing because they're people themselves. So they might think they understand the tasks that are being conducted. They might also think that they understand what people are doing, even if they don't have actually the data proving that, that is actually what they're doing, and the statistics don't necessarily work to their advantage. And then this general inexperience across the board is also a problem, combined with a the general fear of missing out also, of course, is that these techniques are good. They are powerful. You can use your data for things that you couldn't do before. You can meet or exceed human performance on a lot of tasks. And of course, we need to do that. But we also run the risk of putting things too early into production and underestimating seriously the investments that are needed to do this in a secure and safe way, and especially a way that is trusted AI, but also trustworthy AI, or even to to put it to the extreme, fractional reserve banking trustworthy AI. So it needs to be something that you can put into use in a bank with the consequences and managing the consequences that it might have if it goes wrong. Just like a lot of the other complicated things that also happen in a bank.
Yeah, and we have it our term as well, like, so you said trustworthy or trusted AI. It was a responsible AI.
Yeah. So it has many names, but for a bank, the worst case scenario would be that it's not fractional reserve banking worthy AI. That it such undermines the trust in your institution that it poses an existential risk.
Yeah, sure.
Of course, that's the extreme end of of fear mongering a little bit here, but that's the perspective that I think this needs to be seen in as well.
Yeah.
Because there's also discrepancy. There's a little bit of a discrepancy between the core risk functions and their awareness of what's going on. And then from the developer side, the awareness that they are working for a bank and it's not a startup company. You can't just start over. It has real consequences for a lot of people.
Okay,
if you
in the sense of it has more consequences for more people. To be honest, as working in a startup, it's always worse if things happen. Not the way expected. What I like about that slide specifically is it's for me it's like a checklist. It can be used like a checklist list. Let's walk through those steps and see what does it mean in my context. What is about technical depth? What is about human task? Did we actually organize everything? What experience do we have? What kind of lack of experience do we have? I think this is pretty helpful.
Yeah. I'm a little bit worried about checklists in general, but I'll come back to that. But of course, there are some good elements of it. But there's also a tendency to, when people are using checklists, that they are not, considering necessarily, the fundamental issues related to these things, which is another thing that inexperience also brings. The overall perspective is sometimes lost on people who don't have that mature view to what it takes and what we're doing, and it's not an easy task. So it's not something that comes naturally from just a few years work in this area. It's typically something that takes a lot of effort and a lot of mistakes that you need to learn from your own mistakes and other people's mistakes over a longer period of time. And that those people are just not very available. It's really hard to come up to find someone who has many years of experience with AI and machine learning, and also practical experience, and then expert matter, experience for the particular applications, and the many nuances that are in as the previous slide showed, that there are many sort of aspects that you need to cater for doing this maturely and responsibly. And that's tricky. So So to summarize a little bit the types of risk here. So there's, I've just tried to do a sort of traffic light, red, amber, green. The red one, of course, is that the AI or machine learning application just doesn't work, which is, I think, where we are for a lot of applications. And of course, the worst ones are those that don't fail quickly, but that you use over a long period of time building up problems, and then you have to clean up afterwards, which is a problem. And even in the event that AI and machine learning works, there are still potential consequences, the societal consequences of, you know, the impact on your workforce, on employment opportunities, on impact on the environment. And then lastly, when AI and machine learning works a little bit too well, you also have problems. And that's actually a lot of the concerns for in the proposed EU AI Act is of that last. So a lot of the prohibited items is AI and machine learning that works a little bit too well. So the evil overlords that knows you better than you do yourself and can exploit and utilize that information against your will. So there's risks in all elements of sort of in the full spectrum of how well AI and machine learning works. Is the key take home. So there's, of course, there's a lot of regulatory now with the upcoming AI Act, which I think is very welcome, that someone else than myself are concerned about these things. So for a financial institution, of course, you need to be compliant with the basic law regulation stuff, the Basel, the CRD, the CRR, your GL11 supervisory stuff, and your internal models, so your credit risk, market risk, pricing models, that they're compliant with these things. But you also have GDPR concerns related to your use of AI and machine learning models, of course, in terms of generating data sets, potentially having those in the cloud or by third-party people. So you're concentrating privacy information for training data in ways that they aren't necessarily in the legacy systems in banks. You have special regulatory requirements related to anti-money laundering and preventing financial crime, which also might be impacted by the use of AI and machine learning. And then just recently, EBA, the European Banking Authority, released a discussion paper on the use of machine learning techniques for internal rating based, so for credit risk, capital calculation of regulatory capital. Where the supervisors in the past have been very restrictive in permitting people to use these types of techniques. So the credit risk models are more or less set in stone. There's very little room for maneuvering compared to when you're building pricing models. And there's a lot of constraints in terms of how you need to benchmark and test and build your models and also validate and test them. So I think what they're trying to do, EBA, is to open up a little bit for the use of these techniques within these capital calculations for credit risk, which is sort of softening up a little bit their view on that. But on the other side, putting some, I expect some limits as well for the general use of AI and machine learning in the financial sector. So not only the things coming out of the EU Act, which is a general for all users, not only the financial sector, of uses of AI and machine learning, where they have this risk-based approach of course, as well. You know, if you're doing complicated things for important tasks, you need to put the right efforts in, and then have some things which are just unacceptable, which was the green sort of societal Big Brother type activities that are outright banned. But then you also have high risk applications, where I think for now, at least, it's only explicitly mentioned. The only reference to CRD in the AI Act is for credit scoring. Financial institutions can also be subject to some of the other ones, sort of for recruitment. But the overall, what can you say? The main driver of the AI Act is the individual rights of the citizens of EU, or of the European Union, and not as much these fundamental financial stability problems. So as relates to banks and the EU Act as it is now, is mostly concerned about whether you can get a loan or not, and not as much concerned about whether you can buy food tomorrow or not, because your money's gone. I think that will change over time. So the definition of AI is allocated to an appendix in the Act, so potentially subject to change. I do like the definition, even you know, having to try to define what AI and machine learning is in a financial setting. It's super hard to do, and there's a lot of gray zones. And of course, we have problems with defining just what natural intelligence is. It's going to be difficult to define what artificial intelligence is, but it's going to run the gamut from statistics, rule-based, and then something in the middle, which is covered quite nicely by, I think, the definition used here, especially when combined with the view on how are these techniques used. So if they're used in a way that puts the citizens in danger, or their rights in danger, or might have a severe impact on them, that will then be treated by this act. So I think the list of naughty applications, so to say, that is also in the appendix will grow over time. And I also do expect EBA to issue guidelines as well, specifically for the financial sector on the more broader use of AI and machine learning outside of the credit risk space.
Because I just see questions at the moment regarding the regulation. If you go back one slide.
Yeah, sure.
Okay. Who is managing such regulations in companies in general? Is there a role for that?
So for making sure that we're compliant, that banks and insurance companies and pension companies are compliant with the regulation, there's a horde of people doing just that. So that's typically done by the compliance functions or your legal team, but everyone else as well, of course, needs to abide by the law.
Yeah.
So everyone is quite aware of what the regulatory requirements are, especially in the risk function, but throughout these organizations. So yeah, that's the short answer. Is everyone, but of course concentrated in what we refer to as the second line of defense. But also, of course, there's audit functions, internal audit functions, making sure that all the controls are in place, and will make sure that the second line compliance risk functions, operational risk, are conducting their work as they should, and also that the first line business, more direct business line is doing what they need to do.
Yeah, I mean, that's just also from a practical point of view, just for you guys who just joined us today, thanks again for being part of our episode today. Since I have been attending EY Startup Academy recently, right? So I was in a lucky situation to find out so much regulation, but it was like scary. It scared the hell out of me. Yes. Also, like, okay, when you just said, okay, we do something. Yeah, usually in startup we do something, test something, we try it, make it, and then you suddenly you find out that there's something where you need to take care of because there are legal threats which you need to take care of. And just coming back to the question again, and I think you partly answered it. But some companies do have the resources of the bigger ones to build up staff in that area. I'm a startup, I wouldn't have capacity to do that. So we need to actually ask outside consultants to do the job, right? And to say, can you help me? Can you check if we are legal, what kind of legal pitfalls might be on our way, which we need to know of, which we are not aware of, even if we have domain expertise because we have been working in the industry for some time. You need an expert in legal issues as well, right?
Yeah. I must say though that, of course, the impact of error or fault or problems are much bigger for large financial institutions than they are for most startups. So if a startup fails, people can buy food again tomorrow. It doesn't spread across the globe to the same extent. So of course the regulatory scrutiny and the requirements set on those institutions are very sort of severe for good reasons. But that doesn't mean that everyone needs to do all these checks and balances, that everyone needs to live in a bank vault for their entire life and be constrained to that. But of course, there's a lot of things that other industries can learn from that perspective of managing risks, of being compliant with regulations, being careful, and but it's also, of course, expensive.
It's interesting that you say that, and you say that we're talking about the financial industry at the moment, but of course, this is just like there's some general truth in it, which can be used in any kind of industry, as you mentioned. For example, we had a healthcare startup. So healthcare is a similar difficult field because this is not about people's life. This is about living, and this is about life, right?
Yeah, you have, of course, some healthcare problems can also potentially propagate out to millions of people. But for most of them, they have a more direct impact on individuals than in the financial sector. There's more of a statistic sort of big game issue for the financial sector. But that also does have some quite potential severe consequences for individuals and for a lot of individuals if it does go bad. But of course, and also that in terms of investing in risk management, it is expensive. And also it's expensive to get people with experience and to invest appropriately. But it's also expensive to not do it. It's even more expensive actually to underinvest in this area. And then suffer the consequences down the line. So actually on that, this is sort of meant to illustrate where financial institutions are when you compare the level of AI adoption with the amount of AI control they have. So of course you have some optimistic people with not too much AI adoption, but a lot of AI control in your top left corner. To my experience, they would definitely be outliers. Might even be liars, because I don't think that is the case basically anywhere. The feedback I get across the industry is that there is actually much more use of AI than people think, and unfortunately there's not enough AI control. So there might be some, especially big institutions that can afford and have done this prudentially in good time. So where you want to be is in your top right corner, right? So that your AI adoption, the control that you have is commensurate with your AI adoption. And you also don't want to be down in your bottom left corner and not use AI and miss out of all the good things. So most people would want to be in your top right corner. But what we do see is that there's variation and there's some distribution, but a tendency to be perhaps down in your bottom right corner. So of course, what needs to happen, especially now with the upcoming regulation and the increased scrutiny that will follow from that, is that you can basically do two things. You can move up, which is sort of the ideal, or you can move left. So basically scale down the use of AI. And I think in reality, what will happen is a little bit, up and to the left. So be less ambitious about rolling out this, but do be more committed to building high quality applications, and also making sure that you have all the controls in place. So as a key element, and this is where the financial stuff comes into play. So we actually have quite a lot of experience with controlling complicated, sophisticated modeling techniques for things where there's a great degree of uncertainty related to it. So various types, of course, there were some issues in the last financial crisis related to exotic derivatives. But there's a whole discipline which is, has been used for decades in the financial sector, especially the large financial institutions, related to the use of sophisticated math and sophisticated computer models for important tasks, which is this model risk element. And a lot of it is sort of, the discipline is based on this SR 11.7, which is law in the US, but is sort of industry best practice for the rest of the world. Before it became law, it was also industry best practice in the US. It was called the OCC guidance on model risk. That the underpinning of that is, in essence, some element of peer review, as known from universities and sort of the field of science more generally, or that you do something, you write it down, and you submit it to scrutiny by your peers before you have it accepted for publication. The same fundamental approach here is sort of set out in SR 11.7, that you should have independent challenge of your models by suitably qualified people who can do this extended type of peer review, where they take your model to pieces, they hit the tires, bump it, subject it to stress, look at all the uncertainties, all the assumptions, all the bits and pieces going in, and write up detailed reports that are then submitted to committees to approve that this is actually fit for the fit for purpose is the essence of it. And there's use a definition of model risk, which is basically just adverse consequences from decisions based on misused model outputs and reports, which is fairly broad. And a definition of model, which is basically just a quantitative method system approach that applies statistical blah, 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 blah. So that takes some input and turns it into output, right? And that can be anything. But of course, if you take a risk-based approach, there must be some element of, is it sufficiently sophisticated and complicated? Is it used for something sufficiently important to merit that you do this costly exercise of getting someone to spend months taking it to pieces, analyzing it from various angles, and making sure that it actually does what it says on the tin? So that's the underlying principle that I think, to my mind, is something which is somewhat unique to the financial sector, that you actually have a dedicated team of rocket scientists in one corner of your organization to make sure that your other rocket scientists are not falling out of line and misleading management, or even misleading themselves in terms of what it is their math is doing. And of course, the central sort of category or label that we put on this when we do model validation is to look at things on a very fundamental level, whether the application is fit for purpose, to make sure that there's alignment between the reality that's being modeled and the model itself.
Mm.
So, and that can be, of course, something that happens over time, that there's drift either in reality changing in ways that the model does not cater for, or that the model drifts in ways that the reality cannot substantiate, or that they are misaligned even from the beginning due to sort of fundamental misunderstandings. Of course, all models are wrong. They are not reality. And that's why we have them, because they also have some features that reality don't have. You can use them to forecast. You can explain stuff with them. But ultimately, it's a simplification of whatever reality you're trying to describe, and you don't want them to be too far apart, especially on the important issues. But that's super complicated to find out and what to do. So I think that the simplest recipe for that is basically to get someone who is sufficiently qualified to have an opinion, sort of second opinion on what is going on, and make a statement on, is this fit for purpose, and write up some level of report that mirrors the model documentation that you require from a sort of a publish or perish type regimen, just as you have in universities, that you require people who want to use or build these models, that they need to write down what they're doing, because you cannot assess computer code alone, or just data alone. You need to subject it to tests, and it's much easier to assess this if you ask someone to write down what they're doing. And also to provide that in a way that other people can understand, and to sort of propagate this knowledge about what is being done. So there's transparency involved in it. Yeah. And as part of that process, but what we do when we do these model validations is that we compare the reality that's being modeled, the data, to the mathematical description, the overall abstract description of the model, what it's intended to do, what is its main driving elements, and then comparing that model, the mathematical specification of what's going on, or the statistics, with what is actually then coded, implemented in software, and then compare the use of that software in real life with the reality that it's being used for. And this is actually, just as a side note, this triangle here is inspired by a paper by Thacker et al. From 2004 out of Los Alamos, used for model validation and verification of nuclear weapons testing. So when they banned actual tests of nuclear weapons and did computational tests of nuclear weapons, these kind of this was sort of a recipe for how to manage that. So it's sort of bringing the loop back of these weapons of math destruction to principles underlying actual weapons of mass destruction, and how you can monitor and use them, and make sure that they, in the event that you do need them, that they actually work. So just taking that sort of full circle back to that. And then in terms of actually, so when we conduct the model validation work, we require people who own the models and develop the models to write down in excruciating details, such that the outputs can, given the same inputs, be replicated in essence, and that enables us to do an assessment of the quality of the model, but also to some extent the quality of and the experience of the people building the model, sort of the quality of the model documentation, to have access to the code, and to have access to the data, which includes input, output, and also parameters. And then we subject this to months of scrutiny and running tests on, what is the use? Is it suitable for this particular setup? Are there any fundamental flaws? What is the training, the retraining, calibration? What is the feature stuff? What are the biases, dependencies? Testing various components, looking at the uncertainties and assumptions, and all this, of course, depending on what the particular technique is and what the particular application is.
Just a quick question between, do you work with synthetic data or do you work with simulations?
Depending on what the particular application and the particular technique is.
Mm-hmm.
So of course, there's a broad range of various types of tools that you can use to probe the validity of any model or any particular AI or machine learning application, but it depends on what it is. So it's very hard to give a generic recipe of what needs to be done. Also in terms of explainability or bias or some of these other sort of hot topics, which of course are important elements of this. But I think to my mind, the main problems with AI and machine learning applications in the financial sector is sort of more the build quality and the maturity of the setting, and not as much the explainability or the bias, even though those are, of course, depending on the application, very important aspects, and also something that you would test for the validation. But then we also now, if we go too much into detail with the particulars of this, we also, of course, end up in some kind of client privilege, competitive issue on what are the gory details, and how can it go wrong in ways that are perhaps a little bit too gory for general public consumption. But it's something that we need to make sure that we have controls for, and the way that you set up those controls is by subjecting it to this type of extended peer review. And then in the end, of course, validators, model validators write up their own reports, their own documentation, with nice executive summaries for senior management to digest and understand the implications of it, and all the relevant background and all the results and recommendations for what needs to be done in terms of outstanding assessments of the risks, and also suggestions for how these can be mitigated or potentially accepted as well, if they're unmitigatable. But it's still, paramount to use these techniques, and you're willing to live with the risk. That might be the case sometimes. And then lots of tables, data, references, equations, and the likes. And then from a broader sort of scale picture, these are that's what you do for individual applications. Then for all your applications, of course, you need to identify your models or your AI machine learning. If you sit sort of on top of your organization and need to be aware of, are we on top of our risks here? You need to identify your models, which can be tricky, especially concerned, related to how you would otherwise identify your legacy models, your pricing models, your market risk and credit risk. It's easier to backtrack from your balance sheet where those calculations are, where they feed in the magnitude of them, than a lot of these applications, which can be used throughout your organization and also might impact you more indirectly on your balance sheet via fines or reputational risks. So that's a problem. And also it can be, purchased by, vendor models purchased by someone that are not centrally registered necessarily. Everything, of course, is centrally registered if it's a bank, but people might not be aware that they're buying something with a sophisticated AI technique or machine learning in the box, so to say. And also by someone who's not necessarily accustomed to statistics or quantitative measures. So if it's someone in HR who've bought a vendor solution for assisting in recruitment, they might not be aware of the regulatory expectations and general sort of risk management expectations on dangerous math to the same degree as your credit risk models. So that's one element. And then, of course, gather the documentation, track the governance decision, make sure that when you're looking at these applications that you have some element of tiering, so you can still do a risk-based approach where you're mitigating and risk management activities are commensurate with the risks that there are in these applications, conduct the validations, do use recommendations and restrictions potentially, and approvals for use to make sure that you do things by the book, and there's a trail on how that's done. Monitoring your models and applications in production, looking at the retraining and adjustments if they're necessary, and then of course also updating your reporting as to how these models are performing. And then associated with it, there's a governance process with roles and responsibilities ranging from, you know, people responsible for the model, people developing the model, various types of control functions, in addition to the, you know, the model validators and the model users and owners. That also needs to be set up and defined, typically in policies that are applicable for the entire institution. But that needs to be refined for these AI and machine learning applications as well. And then specifically for model risk management and AI validation, to update model risk management broad guidelines to make sure that they cater for these types of models as well, to set up specific validation guidelines for these types of models. So somewhat tweak the existing rules and guidelines for how you manage your legacy models to also cater for the characteristics of and particular risks of these new types of models. Consider whether you have the adequate validation teams and updated charters for those, if you want to set out that route, and that you have appropriate representation in your governance bodies, so they can take the right decisions and understand the extent and the level and the characteristics of these types of models as well. Update reporting, get the identification done from the validation team, which are most likely to be able to spot and identify and tier these models. Set up validation plans, so make sure that you've seen things in a timely manner, and identify stakeholders across your organization, not only users and developers, and make sure that things are anchored in management, but also across second line, that you have compliance and operational risk and security risk, your legal and your audit teams aligned on the types of issues that can arise with these new applications and new techniques. And then, of course, from a practical point of view, from validation, you also need infrastructure. You need compute resources, you need access to data, you need data scientists, validators, of course, but you also need the data, and to build the tools and be able to conduct the tests that you need to do in a timely manner as well.
Yeah.
And then potentially, lastly, also support the development side by making development standards that that developers and users need to abide to. So it's important to also, from a resource perspective, because this sounds terribly expensive, right? To keep in mind that your model, the fundamental abstract thing that you typically would assess as a model validator, is only the tip of the iceberg. There's always more stuff underneath in terms of governance, and, you know, getting the appropriate staff in place, making sure you have controls and things related to your data, ethical aspects, the basic operations, making sure that it doesn't break down constantly, and that you have the appropriate infrastructure for running this. That's the vast majority of your resources are not going to be put into these, you know, fundamental elements of does it do what it says on the tin. But regardless of that, your model, the bit that sticks above the water, is still fully capable of sinking your Titanic project if it does hit the iceberg. So of course, you need to be mindful of these more general, generic aspects of what it is you're doing, and preferentially before you start spending all your money on the operations and the infrastructure and all that stuff. Yeah. So is it fit for purpose? Should be the first thing that comes into mind when you want to run any of these projects. And then, of course, also on the resource consumption related to the control side, it doesn't take that long time to write up rules. Of course, consequences of bad rules can be severe and significant, but just providing the documents doesn't necessarily take up that much effort. It takes up a lot more effort to do the controls, to conduct continuous model validation and monitoring and making sure that you do that. But the vast majority of your consumption is going to be in your development, so being compliant with the rules. That's where the real resource constraint actually is.
Yeah.
Even though it looks a little bit perhaps like all these controls are sucking everything out of your business that you need to comply to all these requirements. To my mind, still the main task is building and using these models, and that's also where you're going to spend the most of your hours, and also where the impact is going to be biggest if you do make mistakes. And then lastly, of course, all this is sort of ideally, if you're a large, globally significant financial institution, then you need to have an AI risk framework in place, and also potentially to have a dedicated AI model validation team. And a center of excellence and control across the second line. But if you are not a global significant financial institution, you still need to have an AI risk framework in place. That's the easy part. Those are the documents. So if you're a medium-sized bank, you can upgrade your existing validation function that you have if you're in a medium-sized bank to potentially cater for these types of models as well. I think most places actually do have a center of excellence, even if they're not necessarily these massive international institutions. Of course, there's some level of variation of how much the size of your center of excellence, also how centered it is, and of course also how excellent it is. So some variation there, but most people are actually setting up some shining city on the hill for the rest of the developers that they can mimic, and they can go to and ask, how do we do things in a compliant and in a good way, and how do we make sure that we don't set out in overly optimistic projects and be surprised by the level of governance related to using these types of applications in the banking sector. And then lastly, sort of in this gold, silver, bronze type of approach to AI model risk management and AI risk management is that for smaller banks, insurance companies and hedge funds and other sort of not as heavily regulated entities, I think making the documents and setting up some kind of center of excellence and alignment across your second line is still needed, but you might get away with only not doing model validation per se, but more sort of risk assessment in a more broader sense related to these models. So a little bit like what we discussed on the difference between being a bank and being a startup company. Yeah. So you can utilize some of the same principles, but you don't necessarily have to do it with all the bells and whistles that comes with having a dedicated AI model validation team.
Yeah, Luca is asking why you put insurance here and the third tier. Is there any reason for that, or is it just like it happened?
So in insurance companies are generally not as heavily regulated as banks are.
So it's actually related to the regulation and the intensity of regulation. Yeah.
But of course, regulation is also related to the underlying risk. So it's not just out of being compliant with someone because we need to be compliant. There's good reasons for the extra level of scrutiny on banks and credit risk, credit institutions generally than there are on insurance companies or hedge funds or small banks.
Yeah. From your experience, and that was one of the questions earlier, which perfectly fits now. are all AI machine learning projects subject to regulations?
Depending on the use, I would say. So if you use it for something which is really important, yes. If you don't really use it, or whatever you're using it for is sort of, relatively benign or unimportant, then in a risk-based approach, you would not need to do anything but just assure that that is actually what's going on.
So if you say use, now is the kind of rule of thumb to say like, hey, look, if your AI model affects the people's life in the sense of the money aspects of people banks or the geographic area, this is getting more and more and more. Is it something like that, or?
Yeah, and for financial institutions, there's typically, especially for operational risks, there's typically some sort of framework that are set up, or scoring schemes that can enlighten you in terms of, is this important or not important?
Oh yeah, so
is it going to cause instant calamity, or is it something with a low probability of something bad happening, or and if the impact, it's only going to be so for financial institutions, most risk is measured in money.
Yeah.
So it's not measured in lives or lost limbs, but quantified in terms of monetary loss.
Yeah.
And I think that's a good guiding principle for in this industry, at least, is to translate these impacts into potential loss. But it can be difficult, I think, and also that's one of the main challenges here, is to find out what is the actual impact. And how does it impact when it's this more indirect nature?
Yeah.
But I think sort of basic sanity checks is, what would happen if you just pull the plug? Or you say that you think it's been doing what it's been doing, but in reality it hasn't been doing this for this period of time. So whatever obligations you had that you thought your machine was doing, what if you actually haven't fulfilled those? What would be the consequences of that in terms of fines or reputational impact or other types of financial loss?
Yeah, an interesting aspect you're just raising, because I was thinking of a video I saw about the CTO of Palantir. I guess you know Palantir. I suppose that most of your audience have heard of Palantir as well. So the interesting part of it, because this seems to be high tech, really, like modeling supply chain effects and military operations and what happens in terms of prices and whatever. This seems to have heavy stuff, right? The interesting part was when he said, actually, it's more like an augmented AI. So it's not that this whole thing is doing something without a human in the end. It's more like adding value to someone who has still to make decisions. And I think it's the same like healthcare again, so where we have augmented AI in many cases as well, where it's just like in the end it's the physician, the doctor, who decides what to do, and there's a suggestion thing like that.
Yeah, and of course it. So what's typically done for model risk is that for the tiering is that you consider the complexity of your application and also of the problem that you're trying to solve.
Yeah.
The exposure in terms of what is the potential monetary loss or financial loss, and then some degree of reliance. So do you have a human in the loop?
Yeah.
Have you replaced a human completely? So there's full autonomy of the system. Do you have alternatives to your model that can also, does it rely on, is there a high degree of uncertainty related to it? So it depends on input that you cannot observe. So unobservable parameters and all that stuff that relates to this element of how much do you trust it and how much do you put your life in the hands of this particular setup. But also, of course, if you do claim that you have a human in the loop and you're only augmenting, and that this human is actually mitigating some of the risk, you still need to test that is an adequate mitigant of the risk.
Yeah.
So you put reliance on the human and that they can actually safely do that. So I think, and you're still interested in both, of course, identifying and managing your sort of inherent risk of your AI and machine learning application or model, but also the residual risk that you have after. So I think my being a biologist, my sort of the best image I have is from if you visit a zoo. So the most dangerous animals, I don't know, tiger or something. Inherently most dangerous animal is the tiger. But so the residual risk that you're most subjected to is probably, you know, in the petting zoo. But of course, you need to, you know, an actual damage most likely would be from, you know, a goat or something like that in the petting zoo. But you need, of course, to make sure that, you know, the bars are in place, there's a lock on the door in the tiger den as well. So that the risk is identified and mitigated, and that those mitigations are adequate for the risk. It is still vital for managing your risks, and that goes for these applications and augmented setups as well.
Interesting.
So I think that's
building a better world. Okay, that's a good idea.
Trying one step at a time.
Exactly.
So that's basically my presentation for tonight.
Thank you very much, Søren. Yeah, thanks for sharing all the insights. We took, of course, a little bit longer, maybe in your evening hours of thinking back, but it's also private time in some ways. There's one, let me check, one question open. Look, I think you need to explain that a little bit because I'm not really sure what you mean with spiders, insects, and bacteria. Or maybe in terms of risk factors as well. But anyway, I think,
you know, different ends of the spectrum.
I think so. One thing to say is you're reachable on LinkedIn. So this is basically where by introducing from Francesco to you, we reached out to each other as well on LinkedIn. So please, for everyone who is still open questions, I'm looking at the time a little bit because I know everyone has also some private life here. I think it's probably open to answer questions. I think it was very intense. I liked it very much. Enjoyed personally. I enjoyed the discussion here, the talk with you. And it was also awesome just to see your deep level of expertise in the field, which is like, cool, man.
Thank you.
Thanks for that. So for anyone else, because the question was also raised, yes, the session was recorded and is still recorded. We will make it available on our YouTube channel again. Thanks again. Yeah, here, Luca, that was the question. What are the most dangerous but often overlooked risks? Maybe the last question. Do you have an idea? What are the most overlooked risks from your background expertise?
It's difficult to say as a general sort of across the industry. Problems are very much sort of individual. I think that the key risk drivers, though, are some that are shared across the industry, and that's what sort of as EY that we've seen examples of. Of course, some people are on top of their risks and manage it and don't make the same mistakes, but these are sort of general characteristics. Those are the ones that I've tried to highlight, and those are also the ones that I think, if you want me to provide a short list, those are the ones.
I think it's also probably problematic because it's still a young area, right?
Yeah, and so maybe so one perhaps word is sort of inexperience or immaturity as an underlying theme. Is the major problem associated with these things, and also one of the most tricky things to mitigate and compensate for. So because where do we find experience to the degree that we need it?
Yes. Yes, fully understand. Yeah, thanks again for this last question. Again, thank you everyone who joined us today. And whatever time it is on your side, I know it's sometimes very difficult because sometimes it's morning hours, it's evening and late night hours. It could be everything because we are spread all over the place. Thanks again for joining us. Please stay healthy. We still have the same stuff happening since 2 years. And I just hope that everyone just goes through the crisis without any issues. Thanks again, Søren, for taking the time and have a good time with your family.
Thank you. Thank you too.
Okay, bye.
Cheers. Bye.